Welcome back to the Neural Intel Pod. We're diving into a paper today that's really making waves.
Yeah.
It's called Exploring the Potential of Encoder-Free Architectures in 3D LMMs. And it's kind of challenging a lot of assumptions in the field.
It's really shaking things up. We've relied on these separate encoders
Yeah.
to process 3D data and then feed it to a language model. This paper's asking, what if we just got rid of that middleman?
That's a bold idea. What sparked this whole encoder-free thing? Were there limitations people were seeing?
Yeah. Traditional 3D large multimodal models, or LMMs, right?
Right.
The ones with the separate encoders had a couple big problems. First, they had trouble with different point cloud resolutions. Think of a point cloud as a way to represent a 3D object digitally.
Okay.
Like a constellation of points in space. More points, more details.
So a high-resolution point cloud would be like a super detailed 3D scan, and a low resolution would be more like a rough sketch.
Exactly. And the problem was that a model trained on high-resolution point clouds
Yeah.
would just totally fail if you gave it a low-resolution one, even if it was the same object.
Right. So it's like if you taught someone to recognize a face from a really high-definition photo,
Yeah,
but then show them a blurry security camera image, and they can't pick out the same person.
exactly. And the second issue
Okay.
was this thing called embedding semantic discrepancy.
Okay.
It's a mouthful, but it basically means that the way the encoder was trained to represent the data, the 3D data,
Okay.
didn't always match up with what the language model needed to
Right.
really understand it. It's like they're speaking two different languages.
Ah, so a communication breakdown.
Exactly.
Right.
And this is where encoder-free architectures come in.
Right.
Researchers wondered, what if we just got of the encoder
Yeah.
and taught the LMM to just handle 3D data directly?
How do you teach a language model to understand something as complex as 3D data?
Yeah. That's the question.
That's the big question.
And these researchers actually came up with two really clever strategies to do it. First one is called LLM Embedded Semantic Encoding. It's about teaching the LLM to understand the core concepts of 3D objects during pre-training.
Hold on. When you say pre-training, what does that mean for these models?
So pre-training is like giving the model a basic education.
Right.
Before you give it a specific job, you feed it a ton of data, in this case, both 3D objects and text descriptions,
Okay.
and let it learn general patterns and relationships. It's like teaching a kid the alphabet before you ask them to write a story.
So you're teaching the LLM to see in 3D.
Exactly. And the way they do this with LLM embedded semantic encode is really cool. They start by converting the point cloud data into something the language model can digest.
Okay.
Kind of like translating it from 3D coordinates into a language the LLM can work with. Then they actually make the early layers of the LLM adaptable so they can specialize in 3D encoding.
So you're actually tweaking the LLM
Yeah.
to make up for not having the encoder.
Right. And then they use something called a hybrid semantic law.
Okay.
It's basically a way to make sure that the LLM is actually extracting meaningful 3D representations during pre-training.
So it's like a coach,
Yeah.
making sure the model is learning the right stuff.
Exactly.
I'm starting to see how they're building this 3D stuff right into the LLM. What about the second strategy you mentioned?
The second one is called hierarchical geometry aggregation, and it focuses on helping the LLM understand the 3D structure of an object, kind of like how traditional 3D encoders work.
Okay, tell me more about this hierarchical approach. It sounds kind of complex.
Okay, think of it like this. When you look at a 3D object, you see different details depending on how close you are, right?
Right.
So from far away, you see the overall shape, but up close, you see the finer details. Hierarchical geometry aggregation tries to mimic this. So in the early layers of the LLM,
Yeah.
they use techniques like grouping nearby points to help the model focus on those fine-grained details. Then in later layers, they reverse it so the model can still grasp the whole object.
So it's like the LLM is zooming in and out,
Yeah,
getting a close-up and a wide-angle view.
exactly. This multi-level understanding is what lets the LLM get the whole picture, like a 3D encoder.
So we've got these two strategies to make encoder-free models work, but do they actually translate into a real model?
That's the cool part. They built this model called Enel.
Okay.
And get this, it goes head-to-head with the best encoder-based models out there.
So this encoder-free model is competing with the best. Wow.
It's pretty amazing, right?
Yeah.
And here's the thing. Enel is built on a smaller LLM called Vituna 7B. A lot of the top encoder-based models use these massive LLMs.
Right.
So Enel is not only getting great results, but it's doing it way more efficiently.
Smaller, faster, just as good, big win. What kind of tasks are they testing Enel on?
One is 3D captioning. Enel has to analyze a 3D object and then describe it in words.
So it's not just recognizing the object, but actually understanding it.
Right. Enel scored 50.92% on this.
Okay, impressive. What other benchmarks do they use?
Another one is 3D classification. So you show Enel a 3D object, and it has to put it in the right category. Like imagine showing it a chair,
Uh-huh.
and it has to say furniture.
So it's like those what am I riddles, but with 3D data.
Yeah. And Enel got 55.0% accuracy, which is amazing.
That's really good.
It shows that training a LLM on 3D data directly really works.
What else? There's got to be more.
They also wanted to see how it would handle 3D visual question answering, or 3D VQA.
Okay, so they show Anal a 3D scene and ask it a question about it.
Yes, Enel will have to analyze the data, understand the question, and give a good answer. It's a real test.
So it has to actually think about the 3D world.
Exactly.
That's cool.
Enel got 42.70% accuracy on that one. Not as high as the others,
Okay.
but still really good for an encoder-free model.
Wow. This is really complex stuff.
Yeah.
It's amazing what they can do with these models.
It is, and Enel's efficiency is really important. Getting these results with a smaller LLM like Vicuna 7B is a big deal.
It seems like this is just the start. Are people already thinking about other applications?
Oh yeah, this is still early, but the possibilities are huge. People are looking at robotics, where robots could understand what you're saying and interact with the world more naturally.
So you could tell a robot, go get me a glass of water.
Exactly.
And it would understand.
And it goes beyond that. Think about augmented reality. Your AR device could understand what you're saying and integrate information into your surroundings.
So your AR glasses could tell you where the nearest coffee shop is and guide you there?
Precisely. And even in medical imaging, these models could analyze scans, find problems, and maybe even help with diagnosis. It's really exciting.
It sounds like things are changing fast. But is there a limit to how simple you can make these models?
That's a great question. You have to find a balance between making it simple and powerful.
So it's a trade-off.
Exactly. That's where the real innovation is, finding that sweet spot between simplicity and power.
It's amazing how far we've come. We've talked about the limitations of the old way, these new strategies, and this incredible model called Enel.
And we're just getting started. In the next part, we'll go even deeper into Enel, looking at its architecture and training.
Be sure to visit our website for all the details. You can find the link in our bio, and subscribe for more deep dives into the latest AI and ML research. See you in part 2.
You know what's really interesting about Enel's success? It's not just about doing better.
Right.
It's about how we think about building these models.
Yeah, tell me about that.
Well, we've always thought that bigger is better, more complex is better.
Yeah.
We just keep adding stuff to these models.
Right.
That's the only way to get real AI.
So Enel is challenging that.
Yeah, Enel's like a breath of fresh air. It's saying that maybe LLMs can understand 3D on their own.
Right.
We just haven't figured out how to let them do it.
It's like we've been putting training wheels on them.
Yeah, exactly. And Enel is showing us that by taking those training wheels off, by getting rid of the encoders,
Yeah.
we might be able to get something even better.
It's like we're finding hidden talents
Yeah.
in these LLMs.
Exactly. And this is a big deal.
Right.
Not just for 3D,
Yeah.
but for all of AI.
So what are the implications here?
Well, first, it could make AI more accessible.
Okay.
Smaller models, less computing power. That means more people can work on this stuff.
So it's democratizing AI.
Exactly.
Okay.
And another thing is sustainability.
Right, we can't forget about that.
With smaller models, we use less energy.
Yeah.
Which is good for the environment.
So it's a win-win.
Exactly. More efficient AI that's also good for the planet.
And it could lead to more integrated AI models, right?
Yes.
What do you mean by that?
Well, right now, we have different AI models for different things.
Right, like language, vision, 3D.
But what if we could combine them all into one?
One model that could do it all.
Yeah. Anal kind of shows us how...
It's like breaking down the walls between different parts of AI.
Exactly.
So AI could understand the world more like humans do.
Exactly.
That's exciting, but also a little scary.
Oh, yeah, we have to be careful.
We need to make sure AI is used responsibly.
Absolutely.
But let's focus on Enel for now.
Yeah, the model that's proving that encoder-free can work.
We've talked about how well it does, but what about the details? What's going on inside?
Well, remember those two strategies, LLM-embedded semantic encoding and hierarchical geometry aggregation?
Yeah.
They're a big part of how Enel works.
So it's not just theory.
No, it's all built into Enel.
Let's start with LLM-embedded semantic encoding.
Okay, so remember how we talked about teaching the LLM to see in 3D during pre-training?
Yeah, like a crash course in 3D.
Exactly. They do this in Enel with something called a token embedding module.
Okay.
It converts the point cloud data into something the LLM can understand.
So it's like translating 3D coordinates into a language the LLM knows.
Exactly. And then they make the early layers of the LLM adaptable.
Right, so they can focus on 3D.
Yeah. Those early layers basically become the encoder.
Okay.
They learn how to understand 3D objects.
So they build the encoder right into the LLM.
Right, and then they use the hybrid semantic loss
The coach.
to make sure the LLM is learning the right stuff.
Right.
This pre-training is really complex.
Yeah.
It's amazing that they can teach the LLM to see in 3D like this.
But that's just the first step, right?
Right, then there's instruction tuning.
Where Enel learns to do specific tasks.
Yeah, like captioning and classification.
And that's where hierarchical geometry aggregation comes in.
Yes. Remember the zooming in and out?
Right, getting the details and the big picture.
In the early layers, Enel groups points together to see the details.
Okay.
And then in later layers, it spreads the information back out.
So it builds up a complete understanding of the object.
Exactly. This lets Enel understand both the small details and the overall structure.
So it's thinking about 3D in a really smart way.
Yeah. And it works. Enel's performance shows that Encoder-Free is a real contender.
It's amazing what they've achieved.
Yeah. And it's just the beginning.
I can't wait to see what comes next. But before we move on, I want to talk about something you mentioned earlier.
Okay.
More integrated AI models.
Right. Breaking down the barriers between different areas of AI.
Yeah. Enel gives us a peek at that.
It does.
But where do you see this going in the future?
I think we're heading towards AI that's more like human intelligence.
Okay.
AI that can understand and interact with the world in a more complete way.
So instead of separate models for different things, we'll have one model that can do it all.
Exactly. Imagine an AI that can read, see, understand 3D, and talk to you.
That's a powerful idea. It's like creating a true AI.
Yeah, and Enel is a step in that direction.
It's an exciting time for AI, but we have to be careful too.
Absolutely. As AS gets more powerful, we need to make sure it's used ethically.
That's a responsibility for all of us.
For sure.
But for now, let's enjoy the excitement of Enel.
Yeah, it shows us what's possible when we challenge our old ideas.
This has been amazing.
It has.
But before we wrap up, let's go back to Enel.
Enel, the model that's showing us the power of Encoder-Free.
We talked about how well it performs, but I want to know more about how it works.
Okay, so remember those two strategies, LLM embedded semantic encoding and hierarchical geometry aggregation.
Yeah.
They're really important for Enel's design and training.
Right, so they're actually built into Enel.
Exactly. Let's start with LLM embedded semantic encoding. Remember how we talked about teaching the LLM to see in 3D during pre-training?
Yeah, giving it that foundation in 3D.
Right, and in Enel, they use a streamlined token embedding module for this.
Okay.
It takes the raw point cloud data and turns it into something the LLM can understand.
Like translating it into the LLM's language?
Exactly, but it's not just about translation. They also make those early layers of the LLM adaptable.
Right, so they can learn how to encode 3D.
Yeah, those early layers basically become a replacement for the separate encoder.
So they've built the encoding ability right into the LLM.
Exactly. And then to guide this learning, they use that hybrid semantic loss we talked about.
Like a coach making sure the LLM is learning the right things.
Yes, it helps the LLM learn a good representation of the 3D objects.
This pre-training is really impressive.
It is. It's amazing how they've done it.
But that's just the first part, right?
Right, then comes instruction tuning.
Where Enel learns how to actually perform the tasks.
Yeah, like those benchmarks we talked about.
And this is where hierarchical geometry aggregation comes in.
Exactly. Remember that idea of zooming in and out on the object?
Yeah, getting both the detailed view and the big picture.
Well, that's what they do with hierarchical geometry aggregation.
So in the early layers of the LLM, Enel is focusing on those fine-grained details.
Right, by grouping points together.
And then in the later layers, it kind of zooms back out.
Exactly, so it can still understand the object as a whole.
So Enel is building up this really sophisticated understanding of the 3D object.
Yes, and this is what lets it do so well on those tasks.
It's really impressive what they've accomplished with this.
It is. It shows that encoder-free architectures can be really effective.
And it's exciting to think about what this could lead to.
Absolutely. This is just the beginning, I think.
We've talked a lot about Enel, but this is about more than just one model.
Right. It's about a whole new way of thinking about AI.
Enel is like a signpost pointing towards a really exciting future.
I agree. It's showing us a path towards more efficient, more accessible, and maybe even more powerful AI.
And we've only just started exploring what's possible with this approach.
Yeah, there's so much more to discover. You know, we've been focusing on Enel,
Yeah.
but Enel's just one example, right?
Right. It's more about the big picture.
Yeah, encoder-free architectures have a lot of potential.
Definitely Enel's like a proof of concept.
It is. It shows us that this new approach can really work.
And we've talked about some of the possibilities like robots and AI.
Robotics, augmented reality, medical imaging. Yeah.
Okay, give me the big picture then. What does the future look like with encoder-free 3D LLMs?
Imagine robots that can actually understand you.
Okay,
Not just pre-programmed tasks, but real understanding.
so I could say clean up the living room and the robot would just do it.
Exactly. They could work with us in homes, factories, anywhere.
Like super smart helper.
Yeah. And AR could be seamlessly integrated into our lives.
I'm picturing AR glasses that can understand what I'm saying.
Exactly. You could ask them anything, like, where's a good coffee shop? And they'd guide you there.
Wow.
And in medicine, imagine doctors using AI to analyze 3D scans,
Yeah.
finding tiny problems that humans might miss.
And even suggesting treatments.
Exactly. It could change healthcare completely.
This is incredible stuff. But we have to be careful with this technology, right?
Absolutely. We have to make sure AI is used ethically.
That's on all of us.
It is. Researchers, companies, everyone.
This has been a really fascinating deep dive.
It has.
We've covered a lot of ground, from the technical details to the big picture implications.
Enel is a great example of how AI is constantly evolving.
It really shows the power of innovation.
It does.
So if you want to learn more about Enel and encoder-free 3D LLMs, check out the paper on our website.
Yeah, the link's in our bio.
And be sure to subscribe to the Neural Intel Pod for more deep dives into the world of AI.
Thanks for joining us.
We'll see you next time.